Hey guys, this is chapter 1, section 3 notes. Doesn't say up here at the top, but it is chapter 1, section 3. So why in section 2 did we teach you how to find x and y intercepts? So you could graph them, of course. So you take a look here, number 1. Some people refer to this again as the cover-up method. I can't literally cover it up because I'm using this video device, but if you could imagine that we were to cover up the minus 5y, and again, the reason for that is all intercepts have a coordinate of 0. So if we were to plug a 0 in for y right there, it would make them go away for all intent and purposes. So what would I be left with? I would be left with the 2x, cover up the 5y or the minus 5y and make them go away. If he's gone, there's all I have left. If that's all I have left is an x, I can solve for x, divide by 2. I got my x-intercept. So writing -5 in this blank would be fine, but to be more specific, if it's going to occur on the x-axis, it's going to be -5 comma 0, which means this guy has got to be 0 comma something. So again, go back to the original problem. This time, if we plugged in a 0 for x instead, it would make the x go away. And if the x went away, the only thing that would be left would be the -5y and the 10, -10. So again, solve like you normally would, divide by -5. And I get +2. So there we go. So it's pretty darn easy to graph with intercepts, and kind of depends on the form of the equation. So that equation is in what's called standard form. We talked about that before. And if it's in standard form, this is usually the easy way to go. So an x-intercept -5, 1, 2, 3, 4, 5, would be right on the x-axis. Y-intercept 2 would be right on the y-axis. So let's see if I can use the line feature without messing this up too bad. And all it takes is 2 dots. I mean, we could have done more dots for sure, but if 2 dots makes a straight line, which you were taught in geometry, that's technically all we need. So here we go, graphing with intercepts, one on the x-axis, one on the y-axis, and we got it, simple as that. All right, number 2, I'm going to start off with covering up the 1/2 x first, just because I'm going to take the easy way out. So if I cover up the 1/2 x, make it go away, no fraction, pretty simple problem to solve, divide by 3, I get 1. So the y-intercept is 1. So don't panic with this other one. All right, if I cover up the 3y, I make him go away. Here's what's left. But everyone seems to forget that a fraction mark means divide. So that says divide by 2. To get rid of it, I could just times by 2. And x is 6. And once you get this far, it's a no-brainer. Just got to find 6 on the x-axis. I got to find 1 on the y-axis. And I just got to connect them. Bingo. And please, I'm asking you, put some arrows on the ends of these. If you don't, go back to geometry. Technically, it's called a segment. These are not segments, they are lines. They go on forever. So please indicate. All right. So there's a couple examples of graphing with intercepts, which is pretty easy. So the other way to graph would be slope-intercept form, which I think you're probably more used to. And it's just kind of simple as this. What's the equation look like? The last 2 equations we did were standard form. If you're given it in standard form, then it's usually easier just to graph the other way with the intercepts. But if it's in slope-intercept form or easy to get in slope-intercept form, then you might as well go with this. So take a look at example number 3. Is the y already by itself? Well, yeah. So we know that the slope is the guy that's in front of the x. So 3/5 is the slope. And we know the b. And some people refer to the b as where to begin. I like that, b for begin. But it still isn't going to help you unless you remember that beginning spot is always on the y-axis. So I always get people who are starting on that x-axis, and it's just dead wrong from the start. So if I have a y-intercept of -2, there we go. So slope of 3/5, and if you forgot, a slope is also known as rise over run. So I get a rise of 3. So I can go up 1, 2, 3. And run of 5, I can go over 1, 2, 3, 4, 5. And I got it. So now we could go the other way, because if you think about it, a negative 3 divided by a negative 5 would also be positive 3/5, right? A negative is divided by a negative. So I could go down 3 instead, and I could go left 5 instead, and that gets me the same line. There we go. So graphing with slope-intercept form, also fairly easy, but again, it kind of depends on the form of the equation. So if you look at number 4 is actually in what's called standard form. But if we were to cover up the 3y and do this problem like we were doing the first 2 problems, here's what I would have left. So what would happen if I divide by 2? Is that going to come out even or not? No. So we would have a decimal, which means I got to graph a decimal. It means I have to graph inaccurately in between grid marks, and that could be kind of a pain. So what we could do is we could just get y by itself. So how do we get y by itself? Well, I need the y alone on the left side, which means I need to move the 2x to the other side. So we talked about this before, a little shortcut. If you're moving a positive 2x, he's going to be negative on the other side. Divide by 3. It means I got to divide everything by 3. So I get the y by itself, which is slope-intercept form. I got negative 2/3. Now, if that had reduced, we're going to want to reduce. And 15 over 3 definitely reduces. So 15 divided by 3 is 5. So the slope, negative 2/3. And the y-intercept. Now, again, keep in mind, I'm not starting my graph by drawing on the x-axis. I'm drawing 1, 2, 3, 4, 5 up here on the y-axis all the time. Negative 2/3. Well, how about down to right 3? So that's, again, kind of like a negative down 2 and a positive 3 or right 3. So I'm going to do that one more time, just to give myself an extra dot. And you could do that all day long. I can go the other way. And they're all going to line up. So let's connect them up. Let's not be lazy and put arrows on the ends. And we got it. All right, a third way to graph would be to just graph the information that's given. So this should be the easiest of all. I would like to think or hope that everybody knows if you're going to graph this set of coordinates, negative 2, negative 6, you go on 2, negative 2 on the x-axis, and down 6 along the y-axis. So there's the set of coordinates, negative 2, negative 6. So it says in the drawing it passes, or in the directions, that it passes through that. So I don't have a choice. I've got to go through that dot. So now normally you would be starting on the y-axis and counting your slope. But they have given us the starting point, negative 2, negative 6. We already got it. So what would happen if I tried to go down 7? Well, it's going to go off the graph. So I'm kind of forced to go up. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4. Now, how did I know to go 4 that way? Well, if I went up 7 and left 4, that's the same thing as that slope right there. So, and we're going to talk about which way the line tilts here in the next video. So stay tuned for that. All right, going to connect these up real quick. Again, 2 points minimum. You don't necessarily have to have more than that. Don't be lazy. Put some arrows on the end. All right, number 6. 5, 0 along the x-axis. 1, 2, 3, 4, 5, 0 has a slope of 4. So now how am I supposed to do rise over run if there's no run? Well, we know that 4 is understood to be 4 over 1. So now I can go 1, 2, 3, 4 up and 1 over. And 1, 2, 3, 4 down and 1 over if I wanted to, just to get an extra point. Connect these guys up, and that's it. So if you look at the drawing on the left, it tilts to the left. If you look at the drawing on the right, it tilts to the right. So if you watch the second part of this video, we'll explain why that is and nice, easy ways to check to make sure that you're always getting your drawings right. All right, thanks for watching part 1, guys. Feel free to tune in for part 2.